Hi guys, so in this lectures we are going to see about how you can deploy your small language models on the GPU machines and how you can make its inference faster. So many of you have maybe already trained many small language models, either it's BERT models or Queen models or Llama models. But when you are going to deploy those models to the production, when your user's request is coming, that time the time taken by model to complete that request and generate the output tokens, it's totally depend upon the how you are configuring models, how you have defined inference, then model sweats and all those things. And the time taken by model from taking the user request to generating the outputs, it's called as a latency. And nowadays in productions, it's very important because nowadays everyone trying to utilize that small language models, but when they are deploying those models to the productions, that time latency is causing the very big issues. And because of high latency, the end users may face some challenges, or users experience maybe not very well, and they may try to avoid using that your specific applications. Also, it's cause many issues when your user is asking any specific questions. So because of that high latency, um, it will take a huge time to give the response. So today we are going to see various ways to improve those latencies and what are the various techniques. So let's consider we have utilized the Queen model, Queen 3 model, and it's a 4 billion parameter model. So first technique is like instead of utilizing 32 bits or floats, you can reduce those points to the int 8 or be a float 16. So because of that, you are already reducing a lot of models, large numbers into the smaller ones. Also, you are because of that, it's also reduced the huge GPU memories to the lower one. So that's the first most important technique. But be careful, like don't go towards the quantization for or even 1 bit models are also coming. So they will shrink the model's accuracy huge. So best way either keep int 8 type of that bit or go towards the BF 16 type of loads. So those are the best for the GPU. So this is the first technique. So because of that, you can increase your model's latency or performance by 2x, and also it requires very less GPU memory. Second one is like let's consider just user is asking some questions, and if model is and those questions require just 2 or 3 type line sentences. That time you should always cap your output tokens. So if you limit the output generation tokens, then your latency may be increased by double speed or 2x. Because what happens, the amount of output tokens generated by those small language models, so it's proportional depends upon the its sequence lengths and tokens. So you should always cap or keep the max output token generation, so it will increase that speed. Also, whenever you are giving the system prompt to that small language model, so don't give the huge or big system prompts. That system prompt should be a precise, concise, so that model get to know actually what to do. And if you are passing too many tokens into the system prompts itself, then model may get disturbed, or it may get confused, and because of that, a lot of words it will also try to add the latency. Then next one point is like batching. So whenever one request is coming, so instead of passing one request, you can create the batch of requests, and those can be passed to the model. So based upon that, also you can reduce latency. Third one is like fourth one is like KV caching, means key and value caching. So what happens for each tokens, models try to compute the dot products of keys and values, and because of that, it's taking the lot of times, so huge space because of those dot products multiplication. So if you implement that KV caching, then it will be really helpful for to reduce GPU memories and to reduce the latency. So nowadays the latest VLLM models are coming with those like page attention. So what happens in the page attention? So instead of giving all the blocks for the multiplication in the GPU, so page attentions will try to give the small blocks for those only required attentions, and it will fill the remaining GPU memories. and because of that small pages or blocks, it will also speed up the multiplication. So that's very important. Then it's also depend upon model selection, as I have told you. Like if you go towards the high billion parameter models, then definitely, and if you have limited number of GPU resources, it will cause the issues. Also, you can add the asynchronous process there. So because of that, latency can be increased if another queue request is coming there. So I have explained here a little bit, and apart from that, if you want, if your latency is still not reduced, then you can go towards the TensorRT or VLLM models. And if you want, if you have huge priority for the latency, then you can also go towards the Intel 4-bit, but it will going to give you a trade-off related to the cost and accuracy. So I have covered some points. In the next lecture, we are going to see like in detail page attentions, how VLLM is working, how KV caching is working, how those can be stored. Then the latest models like twin models and all those, how those are utilizing a mixture of embeddings. Then how they are utilizing different types of attention mechanisms. So they are performing at par with the other models like GPT and cloud models, and so many people are utilizing them. So let me know if you have any issues, doubt, or if you want to comment anything here. Thank you.